Hello, everybody, and welcome to 321 Gang's webinar, Managing Complexity in Automotive Engineering. My name is Kara Rawlings, and I'd like to tell you a little bit about 321 Gang before we dig in. 321 Gang are a Platinum IBM business partner and a Scaled Agile training partner. The Gang are the continuous engineering experts and an industry leader in scaling lean and agile practices. We offer our clients a powerful combination of expert IBM and SAFE consulting services, training, and software tooling solutions to accelerate and drive results in the most complex, highly regulated systems and software engineering environments. 321 Gang's engineering expertise can help. Whether you're facing regulatory, economic, or technological challenges, 321 Gang offers industry-focused training and consulting. Talk to us today and learn how we can help you deliver the solutions your team needs. Please take note of the question box in the control panel. We'll be accepting questions throughout the presentation and we'll be addressing them at the end. IBM's Brett Hillhouse is our presenter today. Mr. Hillhouse is the global automotive leader for IBM AI applications. His responsibility includes industry and technology strategy as well as customer success for automotive compliance around the world. His 25 plus years of industry experience includes transformation engagements at global automotive and aerospace OEMs and Tier 1 suppliers. The scope of these engagements include transformation of product development, reuse, strategy and implementation, manufacturing 4.0, supply chain management, and compliance consulting. Previously, he has held several industry and leadership positions at IBM and Siemens, formerly SDRC. Mr. Hillhouse holds a BS in Mechanical and Aerospace Engineering from Cornell University. Well, that's impressive. So, Brett, that concludes the intro, and the floor is yours.
Great. Do I come through okay?
Yep, you sound loud and clear.
Great. All right. So today we're going to walk through a couple of topics. Why don't you go to the agenda slide, the next slide. So what we're going to walk through are what you're seeing here. Go through briefly some trends, business drivers, etc. Talk about some of the challenges that we see in the industry that everybody knows is going on. And then I'm going to try and walk through some areas where we see some really innovative uses of our solutions in addressing those issues. So things around utilizing systems engineering and software engineering, what those digital twins mean and what kind of value people are getting out of those, how we bridge the divide with the electrical and electronics space, as well as what we're doing around compliance and implementation in an agile fashion within automotive development. That's a tough one. A lot of folks have been challenged in getting that to work correctly. And then finally, one of my favorite topics, what are we doing around software engineering reuse? What does that mean? As a mechanical engineer, I know that it's not obvious when you get into it from a mechanical perspective, how software reuse is so different than it is from a product perspective. So let's go to the next chart and the next chart. So I think we know if I don't show a slide on rising complexity, people we're going to show their own version of it. So yes, we know that software is a huge part of the innovation in the vehicles. We know that it is just the major issue that we see in the development and the successful development of vehicles in the marketplace today. Let's go to the next chart. And one thing that's interesting as all that software comes along is something that shouldn't be surprising, in that the warranty costs and the issues that we're seeing are rising just like the amount of software that goes into the vehicles. So what we're seeing is just a continued curve of more and more vehicle recalls based on software defects. There isn't as good a data on the warranty data, but certainly on the software recalls, we can see quite a bit of information, anything that's associated with soft parts in the vehicle. Let's go to the next chart, because what's interesting here is it's not just that we're getting recalls, it's also that we're seeing it impact people getting to market. So it's one thing to say, we're seeing a bunch of recalls, we're seeing some warranty issues. It's also another one where we're impacting the release of these vehicles by not using some proper techniques in software development and how I tie it into the whole environment. Click one more for the build, please. So one thing that we do see is that this bottom statement has been true for a long time, but this is changing, especially the OEMs are really moving and hiring software engineers now, whole departments, buying software companies, partnering with folks to do this well. So more and more that's changing, but there are still some big gaps. And that's one of the things I'm going to talk about is especially some of the gaps around writing C code. And it's a lot to do with technique and the reason why the historical fashion of the old codes versus the new codes is that they have a lot of legacy code they need to deal with, and they have legacy processes and how they've developed it. So we're going to address that a little bit here in a minute. Let's go to the next slide. So, one of the things I like to take a step back on, we know we have all these challenges, we know there's all these issues. There are specific business goals that we are trying to address here. And these are very much interrelated. So we talked about quality, right? We're seeing more recalls. We talked about on-time delivery. Increased reuse is also something that most companies are pursuing, typically though, from a mechanical perspective. So I'm going to cover that in some more detail. It's a deep topic. It's one that, Kara, I'm happy to come back with you guys and do a deeper dive on at a later date as well. But we are trying to address all of these interrelated issues. We're doing a lot of work around process standards and ASPICE, as well as other compliance standards and safety. So safety, cyber, the WP29, R155, all of those things that are top of mind in the industry today. And then secondly, the reuse we talked about, but also this model-based agile development. And how we're doing that. And I'll give an example of how we're bridging model-based development into the electrical environment. Next slide. So how does some of these issues manifest themselves in your engineering process? This is what this top left is trying to show. So these hazard symbols are areas where there are often issues. Where if people are doing some sort of a ASPICE assessment or other assessment, they'll find gaps in their capabilities. It will be a gap in process and typically a gap in the data that they have. The red X's are where it is a huge area of disconnect in an area where the assessors, as well as my own teams out in the field, we see consistently problems. So that's the transfer of system architecture information down to the domains, bound to software and EE. And then as well as back up. How do they interact over time? That is a difficult one. And that's one that we need to address. And part of that is this model-driven approach. The other area is this unit test and integration test. And I'll talk a little bit about that as well, because a lot of times when we see the delays that we talked about on the time to market, those delays that are happening are often because the individual software was working fine by itself, but then as I add a bunch of more software to it, I'm starting to find that they're not interacting the way that we thought. Even utilizing full AUTOSAR architecture, there is a lot of software architecture that needs to go into it and design that needs to go into about how that software is going to interact and how it will work on the actual deployment architecture that you have. So depending on the different buses on the vehicle, the different ECU structure that you have, all of that is going to have an impact. Next slide, please. And at the same time we have all this going on, the industry is moving to new EE architectures. So we're moving from this, kind of a spaghetti wiring view of what you have on the left today with, 100 plus ECUs to something where, we're going to have a lot less. And what's interesting is that today what we're seeing is we're somewhere in between this view on the left and somewhere in between this view on the right. We're having a mix of the older wiring capability and the older architecture mixed in with some of this zonal architecture work. And I often have to describe, especially to folks who are not software engineers, why this complexity is rising by an order of magnitude or more. Because it does look so much more simple, right, from a mechanical perspective, and clearly it is. So part of this means we got to help explain, and I've spent a lot of time on this area with executive teams, is when you wrote a piece of software for an ECU that had a dedicated function on it, and it had a dedicated wire to a sensor and another dedicated wire to an actuator, to write the software that goes on that ECU is really simple. And in fact, in many, many cases, folks are not using any software best practices in writing that code. So it may not have anything about a unique signal ID even. All right, so think about that. I've got a dedicated wire and a signal. Hey, I know what signal's coming back to me. If I move that into a zonal architecture with a bunch more signals coming at it, am I overriding signals? Do I know which one is right? That is an ongoing issue. We always see problems like that out in the field when you have an unintended interaction. I mean, one that I always like to talk about was one that was a consistent problem on a German luxury nameplate, where if you had the driver's side climate control on and you rolled down the driver's side window, you would pop open the trunk. All right, kind of a funny one, not that serious. But think about it when it gets into safety systems and other things, it could be much worse. So understanding how these things are going to interact, writing proper code that looks at the signal that's coming back, the data that's coming back, and make sure before I write it to memory that it has the proper length of data that you expected. This is something that's called, overwriting the memory buffer. That is a easy hacking technique, and we've seen that work even through like FM radio IDs. So coming through an FM radio, you're basically, spoofing that you're an FM radio signal going to the car, and instead you're a hacker hacking into the vehicle. And gaining access to the CAN bus has been proven you can be doing that. So I know everybody's addressing that. I know the industry's been addressing it, but that's just an example of some poor coding and things that we need to be doing better. And it's something that means that we're often having to re-look at all the software that we've written in the past and really understanding what it is, what it does, and does it adhere to best practices from a safety, cyber, et cetera perspective. Next chart, please. So let's talk a little bit about some of those best practices. Next chart. So the first one I want to just talk about a little bit is we start with the systems architecture, the system requirements, and really being able to break that down into some sort of a functional architecture is what we need to do. At some point, we have this functional system architecture that I break down into different domains. Those domains are both, software versus electrical, but it's also domains like, safety versus stability control, or lighting, whatever it might be that I have, sending it off to different groups to work on it. And from there, then I break it down further and I start working on components. And at the component level, obviously we have things such as, AUTOSAR architecture that needs to be in there, and generating and making sure we're doing that to an AUTOSAR standard, whether that is classic or adaptive. And then essentially what we see as a best practice that not everyone is doing is trying to get some reuse even at this level, even before I get into some of the more strategic elements, which is I have software that's being developed at the component level that could be reused on multiple different functions. So as you can see here, the component level may not actually even be part of the architecture associated with the next domain down. So I can reuse something multiple times. It's been developed for a specific reading of information, and that I can reuse that across my logical architecture in many different places. So there's some interesting techniques that go into how I actually start to build that out, even before I start to look at how I'm going to deploy some of those functional elements out to a deployment architecture. Next chart, please. So in this chart, I want to make the point of why, and especially why on the software side. Both from a systems and a software perspective, some of the big benefits are that I'm able to simulate and I'm able to test things very early on. So I'm verifying early. I'm doing very early verification from a model perspective up at the system level, at the software level. And think about this. This is the reason why we do model-driven development in the mechanical world. You have this CAD/CAM CAE systems. You're able to get rid of a lot of the prototypes that you're doing. You're getting rid of a lot of the testing that you're doing. Now, what I see that is crazy is we see more and more folks doing the systems engineering work at a model-driven level, doing this early verification. And then when they go to software, what they start to do is write hand code again. And that is a mistake, to say the least. There are huge savings by being able to develop from the system model down to the software architecture. And instead of writing hand code, use a model-driven approach. You get all these levels of automation that I talk about here down here on the left side. You get early and quick verification, and changes are really easy. An example here, we did one for a luxury manufacturer, fairly simple piece of software around really around their key fob. And the first development, we were doing this with model-driven versus hand code, and we were, I believe it was somewhere around, I don't know, 60–70% of the time. So there were some time savings. That's nice. What was really interesting is when you go to make the next change to that software. You've already set up your test case architecture. You understand all of this use case generation that you have in your coverage. To make the change is really quick. So we're able to make the changes to this key fob software within about 2 hours. The change, when you do it through the manual process, took them more than 2 weeks. All right, so huge step order change when you continue to use a model-driven approach, especially in future iterations of that code. Okay, next chart. So let's talk a little bit about what we see as we get into this electrical and software arena and how things start to work together. And there are multiple components, right? That it's not just the electrical design, it's the network design, it's the chips and board. There are a lot of breakpoints in this. But this is where we see, and we continually get it from our clients, that this is the most complex area that they're dealing with today. And so let's go to the next chart. So what we've been doing is working with Siemens, especially on the capital side, but across all of Siemens engineering products, on how our solutions kind of map into the design process, and then how we start to work to integrate these. And we're doing a lot of work here. We see a lot of good benefits. Clearly we can help with the simplification of the wiring. So as I move to new architectures, you can reduce weight, you can basically optimize the functionality that you have and the performance that you have on the vehicle much easier, as well as being able to do very early hill testing and virtual hill testing. That's one of the most exciting pieces we're working with them on right now, is being able to create not only virtual ECUs that I can test before I even have the silicon, but also that I can do an entire environment. So test it with the architecture associated with the various networking protocols that you have and the wiring setup that you're going to have. Next chart. So what this looks like when you do this is we're really starting to develop this seamless view of, in the seamless flow of information between the whole level of system requirements, system architecture, down to the EE level, and then we're not even showing here down to the software level. So this starts to give me a really complete view of where I am in my development process and how things are being utilized and being able to see where they're being deployed in the vehicle. This level of traceability helps obviously with impact analysis, probably one of the biggest things, but what I want to stress is that this is an iterative process. This is a back and forth. That's what Siemens are working on with us, is how do we truly understand the engineering process and build support for that into our two product sets, and allowing you to really develop this stuff in the way that we know the OEMs and Tier Ones are doing today. So we're working with multiple OEMs and Tier Ones on this process today. Next chart. And the next. Okay, so I won't go into all of these. I do want to hit a little bit on some of the standards and what we're doing. We have an automotive compliance module in our suite that clients are using, and they're getting a lot of benefit from it. We are covering things such as ASPICE, which is a clear one that we have more and more, both OEMs and Tier Ones now applying in their own environments. As well as, of course, we still have all the work on functional safety. The newest one that I wanted to mention is just where ISO 21434 and SAE 21434 come from. In combination with the cybersecurity standard, we also have this WP29 standard from the UN. And right now what that means is, if you can't prove in all the countries that have adopted the WP29 standard, which is all over Asia and Europe, it's not in the US, that's an obvious one that's not been adopted yet, but you're not able to actually sell a vehicle if you can't show that your vehicle meets these standards, and that you cannot do over-the-air updates without having a vehicle security operations center. And the way that you get to put these vehicles into the security operations center is that you have to prove that the design is such that it meets the ISO 21434 standard. So did you develop it with cybersecurity in mind? Does it meet those standards? And then do you have the proper way of being able to manage that security operations center and be able to do alerts, et cetera, that the WP29 R155 demands? Okay, so really a very broad set of regulations, and something that we're seeing a lot of pickup in the industry of folks really addressing this and spending a lot of time and effort on it. And what's interesting is some folks just want to do the security operations center, and we keep reminding them, you can't put a vehicle into that until you prove out and you've developed the vehicle with security in mind. Okay, and this really goes back to the model-driven approach for system architecture. It's that I'm starting to build it not only with safety critical elements in mind, but also with the cyber security elements in mind up front, as well as then into the software, et cetera. Okay, next slide, please. So this is a mapping of our system into the ASPICE standard. And one of the things that we've seen is that there's a lot of advantage of us being able to have clients utilize our product in the way that we are showing that you can, at each individual step, these different work products that need to be created based upon the ASPICE standard, how you use our tools to do that at each of those individual steps, and how you do the linking of the information that is demanded in the ASPICE model as well. And what's interesting is we've seen compliance staff being able to be greatly scaled back after the implementation of this process in our tools, because the compliance is coming along for the ride of people just doing their daily work, instead of having to have a team of folks documenting this ASPICE work that should be done in the tools. They're documented perhaps in spreadsheets saying, yes, we did check this, we did look at this data, it does link to this piece of data, but it's a lot of overhead. So being able to put people back into productive engineering is a huge advantage for those companies that are really doing a nice job with getting to level 3 and beyond. Next step. Next slide, please. Thank you. So one other thing that I want to mention, there's been a lot of implementations of SAFE in the industry and a lot of failures. So a lot of folks are trying to move to an agile framework and really change their development process. And I mean this not just in the software side or the systems engineering side. They're trying to do this across all of their engineering teams. And there are some real problems with doing that. First of all, you have to map back to things like the best practices and all those work products that we just talked about on the previous slide. We showed on there that you've got to create those. Those have to be done. It's not just simple enough to say, I'm an iterative process. Yeah, we'll get to it. We'll get to it. Some of these are going to be waterfall driven. And so we're able to really map the whole idea of doing agile into a framework that supports this idea that at some point I've got starter production, and that code has to be ready on the shop floor, be flashed on the vehicle. And really what we're doing is we're adding the ability for you to have a confidence factor that, we've got 6 weeks to start a production. I'm at 85% or 95% confidence that I'm going to meet that with all the necessary software and functionality in that software that's associated with starter production. All right, so that we'll get there. And so you can see the burn down on that over time. That it's 6 weeks to go, it's at 85. At 4 weeks to go, it's at 90 or 95%. That is very valuable to the, to obviously the chief engineer on the project, as well as just the entire organization. Because this is another area we have to spend some time with. It's a little bit scary, I think, for some of the production teams to see that we're using this backlog approach, this agile approach, and they're not able to see the clear road or clear path to getting code done at the right time for starter production. So this is an ongoing piece that we continue to improve and take feedback from our clients on. But right now, this has been a very big success for us. I've seen other consultants take a similar approach, but it's really marrying the best features of what SAFe can do, what Agile can do, as well as with the best practices from ASPICE. Next chart, please. And what you get out of that is, and this is an actual customer view from from an actual project. This is from a head unit. And what we're looking at here is essentially a traceability view, right? Something that ASPICE wants to see. So here I'm showing that I am being able to look at an individual feature. In this case, they've called a feature here, this slideshow, that's kind of the moving data across the screen. So this is a different English-speaking country that uses a slightly different terminology, but that's basically what that is doing. And then, showing the system requirements down to the software requirements, into the actual model, the design, as well as the linkage back into test cases and test results. All right, that is nirvana and makes the whole process of compliance audits much, much simpler. Next slide, please. And let's move on. Okay, so what we see here is just an interesting view on that there's a set of maturity levels that we see on reuse of software in the automotive market and actually beyond. This is true across multiple industries. And most of the automotive world today has moved into this change management and parallel development area. So somewhere in the middle. I think there were, just a few years ago, I would say there are still quite a few in the baseline area. But that's really begun to change. We're seeing more and more maturity in the industry. As I've said, we're hiring more and more software people and software architects. That's beginning to change, and change management parallel development is a good starting point. And let's talk just a little bit about what that is, and then before we get into the product variants. So next slide, please. So some of these reuse patterns that we're seeing here is that the standard approach in the past has been clone and own. So I've got a project, I've got the software associated with a specific function. Let's say it's, adaptive cruise control. And what I want to do is I'm going to take that code and I'm going to copy it over into my project space, and then I'm going to make some changes to it associated with what I need in my project. You break any traceability by doing that. That's a copy and paste. What we are seeing is people starting to use more and more of this configuration management. So this is variation with branching and merging. This is usually only done at the software level. So that means at the code level. And what that means is that I'm, able to take, a piece of code and I'm able to say, okay, I'm now going to run two separate streams, two different development or, routes. And at points in time, I might be able to merge that code back into the original stream or up to another one. That's good. Second piece is when I move into component reuse is that I want to actually reuse the full component. In order to do that and use it without this clone and own thing, I actually need to use configuration management to address the versions and variants, not just of the code, but now of the associated requirements, the system requirements, the domain requirements. I need to associate it to the various models, the tests, and the test results. So all of that kind of work needs to be done. That's what reuse is in software. It's not just about the code. It's really about the entire set of engineering elements associated with the design. And then we can get into parameterized reuse. This is being utilized probably more at the OEM level, and I'll show an example of this, where they're really doing a tops-down, work breakdown structure of the entire feature set, or people use these terms interchangeably, the entire functional architecture of the vehicle, and showing where they're going to have variations of that and where they're going to add new capability. So knowing that lane keeping's coming, and then knowing that it's high-speed lane keeping, not just lane keeping, but also, being able to change lanes in the vehicle. So all of those are different variations of your ADAS system and different new features being associated with it. So they might map out a 5-year plan of what they know are going to be some of these, new step functions they're going to be adding to the ADAS over time, and really go ahead and map out what those variations are up front. So a tops-down one, managing, up to these, thousands of variation points in the vehicle over time. Next chart. So I want to show this one just to talk about make sure we're on the same page. So when we're talking about being able to manage multiple streams and being able to merge from multiple streams, I want to be able to have these various variants, all these multiple variants, and be able to reuse and ensure I have the data being consistent between them. So in order to do this, as I said before, this is not just about having a stream that's associated with the code. I have to have a stream that's associated with the requirements, with the test cases, the results, the designs, etc. And that's really what is different in our system than what I've seen from any other software development platform, that we're able to really uniquely allow you to pick the right level of the requirements associated with the design, associated with the test cases, associated with the results, that give you a lot of power to have full reuse of a component and be able to create an interchangeable library. That's what we'll show on the next slide. Go ahead. And go to the next slide, please. So here's an example of a product line engineering library or component library, and being able to really easily be able to swap out. And it might be, if you're looking at this from a tier 1, tier 2, you might be able to swap out cruise control for one customer and then find out, oh, later on another customer wants it as well. So version 1.6 is now going to be utilized by program A as well, and I want to be able to easily swap that out. That is very powerful, and as well as allowing the tier 1s to decide, look across their top 5 clients, for instance, and say, here's 80% that's in common. That's going to be my version 1.0. That's my baseline for cruise control. And then I can go look and say, okay, here's the 20% that's different on these other clients. And so that's where we're really seeing some real value on being able to have an 80% kind of model where I'm looking across there, that's all in common, and then I'm only varying the 20%. But what's nice is that those things are now interchangeable, right? That's what they're really getting. And what's also powerful is I start to move towards, over-the-air updates for all of these systems, that I'm able to actually leverage things such as, containerization to make this really simple. You have a sub-container on the vehicle for cruise control. I'm able to just very quickly be able to update that and move it over. And some of the power of that is I'm not having to redo all the testing on this. Okay, so very, very powerful capability there. Next slide. So same kind of idea, except looking at it more from an OEM perspective. Again, being able to swap out something from an ADAS system. And let me just describe this for a second. So what's really neat is, let's say I'm going to pull out this cruise control standard. I'm going to put in the next version. The only thing that needs to be looked at and possibly tested is the interface between the next version of that cruise control and the ADAS system, right? So the interface document is obviously key. If there aren't any changes that are associated with it, there's no testing needed. That's an engineering sign-off. But at most, you're going to have to test where the interface changes are between one version to the next. And that greatly reduces the amount of testing and the potential for additional problems, right? Huge change, and again, supports over-the-air update strategies, et cetera, at the OEM level very well. Next slide. So let's do this not just because we want to, we're doing this because there are some really amazing results out of this. So not only does it look more flexible, does it make the job easier, there are huge quantifiable savings associated with it. So what you're looking at on the left side on the top two bars is a software that's associated with a complex ECU. And the development, the normalized development effort that went into it. The bar at the second bar on there shows a slightly, about 10% more work effort. That's the bar that was done when you designed it with reuse in mind up front. So designing some of those variation points, knowing there's going to be different iterations going in the future, okay? So a little more effort, yep, there's gonna be some investment in doing this the first time, but the second iteration, amazing savings here. So that's over 6x savings. That's the next two bars on the left. So we went from a normalized, level of effort of 16 from the one that did not get, engineered with reuse in mind, down to 3.7 with regards to the one that was done with reuse in mind. So that next iteration is a tremendous savings from just a pure engineering cost and time perspective. The bottom two sets are going to show it for a much less complex piece of code. So think of a less complex software associated with an ECU. And in those, there's more than double the effort to do it the first time, but there's a 3x savings on the next iteration. And across the board in multiple industries, we've seen this. It typically means that there's some associated costs, downstream from this as well. And really what we're seeing is that, is that clients are able to reap a lot of benefit as long as they're going to do 2 iterations on a piece of code. You're going to have more variance. That means you really should be doing this. It's possible if you only have a single iteration, you might not want to do it. It's a one-off. Might not pay back. Other clients are just saying, nope, I'm going to do it no matter what, because we don't know, and maybe it won't be a one-off. Somebody's going to use it and want it. The next one is the obvious one, is warranty claims went down. When I talked about that up front, how do I get quality in? Reuse is how you get quality in. It means that this stuff is tested, it is out there, it's the same code everywhere. And by that, I mean it's the same code everywhere. So let me give an example. If you go and buy a cruise control switch, you need to make sure that cruise control switch has the same software that you're going to use on every other cruise control switch. So that means that software has to support 5-volt and 12-volt control systems. That software has to support a momentary switch on the steering wheel, as well as a sliding switch on the column. So all those things are going into it. This is obviously not just an engineering, this is not just an engineering decision, it's a company decision. But like I said, everybody's doing this from the mechanical perspective. This is the way we do it from a software perspective. And again, tremendous savings. Next chart, please. So why isn't everybody just doing this? Well, because this is hard and this is transformational. The first one I want to mention is, around organizational alignment. Everybody knows there's a lot of complexity. There's a lot of issues going on out in the industry today. I had the chance to meet a couple of clients in between Delta and Omicron, and one of them we were out with was the head of engineering for one of the largest OEMs in Japan. And over dinner, we were talking about all the challenges, everything he had to address, and everything I'm seeing, other clients address. And it was interesting because he had as many stories as you could imagine, anybody having at that level. And I just asked him, what has been the worst thing, the worst date, between the pandemic, between supply chain issues, between working at home, between changes to architecture, regulatory changes. What's been the worst day? What was the hardest thing that you ever had to deal with there? And what he'll say was, I've had the same answer to this for a while now. It is today. Today's the worst day. Today is more complicated. There's more things I'm having to deal with. And when we talked about it, what his organization was, you realize that he wasn't able to support this kind of approach that we just walked through. Why? Because his organization is aligned to the mechanical work breakdown of the vehicle. He has teams that are set up associated with the ECUs, the physical ECUs. So how do I get software? How do I promote software reuse across those different teams? So one thing we talk about is Conway's Law. Conway's Law states that the architecture of your product is going to match your organization, all right? What your organizational structure is. So think about that. If you're organized in that way, you're likely going to have software that's associated and not getting reused across these different teams very easily. We see that across the board. And so we've seen a lot of reorganizations in engineering teams across the planet. All right, Conway, there was actually one from Ford that they called it Project Conway. So taking this very critically and very seriously and really making a change to more of a functional and software-led organization. We've seen this at the Tier Ones, both Conti, Bosch, others have all done the same thing. This is not everywhere yet. This particular OEM, this meeting would have been back in September, October. They changed literally this month. So it took them another 6 months or so, but realize that this kind of change had to happen in order for them to take advantage of some of this more modern and better techniques around software and software reuse, model-driven development, et cetera, and really get commonality in the tools and the processes across his entire organization. There are other issues. I mean, I list some of them down here. If you're a Tier 1, you're probably going to use an 80% BOM versus the 150% BOM. By that, I mean, 150% BOM means that tops-down parameterized model that I talk about from an OEM perspective versus the 80% where I look across my clients and try and find 80% that's in common across my top clients. And again, where to start? First of all, I found limited success if they didn't get the organization changed and start to make some real effort there. So that's one thing that often needs to be created, needs to be done either in parallel or ahead of really adopting a lot of this capability. And then finally, you can do it in an organization. You can start small and just do some ECU on single teams, but you won't see the biggest benefit until you really do it across your organization. With that, I think we can open it up for any Q&A. I wanted to make sure we had time for that.
Okay, great. So if anybody has any questions or comments, please feel free to type them in the question box of your control panel. The one that I have so far is just regarding purchasing tools. Somebody's asking, do they need to reach out to IBM, or can they reach out directly to 321 Gang? And the answer is you can reach out directly to 321 Gang. Our email is info@321gang.com. Just send an email, tell us what you're interested in, and we can connect you with the right technical person and the correct salesperson if we get to that level. So that's the answer to that.
And I just want to say on that, I mean, we have a number of partners, but 321 Gang just has done a great job here for us, especially associated with SAFE and being able to deal with Agile and working in both automotive and aerospace, frankly. So great partner, highly support them, and I'm happy to help them at any time.
Thank you for that. Had a couple of people that are asking if there will be a link to the recording, and there will be. The session was recorded, and it will be posted on our website under the resources tab, 321gang.com. It's the website, and then we have a tab that's called resources, and you will be able to find any of our previously recorded videos there. So I have another question. IBM and Siemens Alliance tool chain is something in development, or is it already integrated?
We already have integration. It is not complete from my perspective in that we don't have a completely hardened approach. So we have it up to the systems engineering into EE. We're still working on automating the back and forth. That's the hard work that's going on right now. So that iteration between them is what we're still developing. I expect to see more of that in next quarter, actually. So you should be seeing a fair amount of this in Q3. And that's basically where we stand. It is demonstrable. We can show you exactly what we have. It's already impressive. And we're happy to spend time jointly on webinars with you, walking you through it, or on site going through this for you. We're doing that at multiple clients today.
Great, thanks. So it looks like that concludes the questions for this session. So as I mentioned, this session was recorded. You can watch it as many times as you like on our website. It should be posted in the next couple of days. So if you have any questions or comments, think of something, please email us at info@321gang.com. And if you're interested in hearing more about any IBM tools or 321 Gang's expertise, please let us know. And Brett, thank you so much for the awesome presentation. We really appreciate it.
Well, thank you for the opportunity.
Goodbye, everyone.